Hello, Algebra 1 students. Welcome back. Today we're going to be doing proportions and similar figures. The first slide is just some symbols that you guys are going to need to know. I'm going to explain them more as we go on and do the problems, but you can always reference back to this slide as you are doing the problems also. So we're going to get started. For number 1 and 2, the figures in each pair are similar. Identify corresponding sides and angles. So what it's wanting to know is what angle on this triangle corresponds with the angle on this triangle. So we're going to write that as, if you see, they're the same shape, but just this one's smaller. So this angle, angle A, oops, I need my pen, angle A corresponds with D, and we write that as congruent. If you see the symbol on the first page, congruent means no matter what, this angle is going to be the same as this angle. So it's angle D. We're going to do the same for angle B corresponds with angle E. And then the last one, angle C, is congruent to angle F. So we did all the angles now, and then now we need to do the sides. So if we look on this triangle, AB will correspond with DE. So we write that as AB over DE because this side corresponds with this side. So now if we do this side, AC, and you can see it corresponds with DF. So we would write AC over DF. And then the very last one, BC, corresponds with EF. BC corresponds with EF. You just look at the sides and the angles and see which one match up with the second figure. I want you guys to do number 2 on your own, so pause it and then we'll come back and see if we get the same answers. Okay, I'm back, and you can look and see what I did. All we did is we saw that angle A right here is the same as angle E over here, and then B and F, and then C and G, and angle D and H are congruent to each other. And then for the sides, all we did, we saw AB is the same as EF, and then BD is the same as FH, and then CD is the same as GH, and AC is the same as EG. I hope you guys understood that. If not, we can answer more questions in class, or you guys can look at this a little bit more. We're going to move on oh, to number 3. So for number 3, they're wanting to know what x is. So the figures in each pair are similar. Find the missing length. So since this side corresponds with this side of this triangle, and this side corresponds with this side of this triangle, we can write this as 3 over 2, and that's this triangle. So this side over this side is equal to, since we put this side first, whatever this one corresponds with is x. So we put x on the top and then put it over, this side corresponds with this side, which is 1. And then we're going to use the cross product property that we learned about yesterday. So we're going to do 3 times 1 is equal to 2 times x. 3 is equal to 2x. Divide by 3, divide by 2 to get x by itself. X is equal to 3 over 2. So this x right here, that side length is 3/2. It's pretty simple, and I think you guys should be able to do it, so I want you guys to do number 4 on your own, and then we'll come back and see if we get the same answers. Okay, I'm back. Look and see what I did. I'll explain it a little bit. Since this x corresponds with this 2, and this 10 corresponds with this 5, I started out by doing x over 10 is equal to, this x corresponds with 2, so this 2 goes on top, and then the 5 goes on bottom, and then we did the cross product property, and then I just simplified and got x is equal to 4. So this x is equal to 4. Hope you guys understand that. And again, we're going to move on. Okay, number 5. So for these ones, they're almost a little bit the same. So all we do is the scale of the map is 1 centimeter is equal to 15 kilometers. So on a map, if you're measuring on a map and you measure 1 centimeter, in real life that's 15 kilometers. So find the actual distance corresponding to each map distance. So on the map you measured zero point 0.2 centimeters. So what we're going to do is we're going to start off by doing 1 centimeter is corresponds to 15 kilometers. So we're going to write 1 over 15, and that's equal to, and since you measured 0.2 centimeters and the 1 centimeter is on top, we're going to put 0.2 on top, and we're looking to figure out how many miles in real life that is. So we're going to put an x. So then we do the cross multiply. 1 times x is x. And then we're going to do 0.2 times 15. X is equal to 3 kilometers. So if you measured zero point 0.2 on the map, it actually corresponds to 3 kilometers in real life. I want you guys to do the exact same thing on number 6, and we'll come back and see if we get the same answer. Okay, I'm back. You can look and see what I did. Hopefully you guys got the same answer. All I did is I used the same conversion, 1 over 15 for the 1 centimeter is equal to 15 kilometers. And I equaled that to, since we measured 4.6 centimeters, I put that on top. And then we were looking for how many that is in real life. So I put the x, did the cross product property, and I did x is equal to 15 times 4.6, and I got my answer to be x is equal to 69 kilometers. So when I measured 4.6 centimeters on the map, that is actually 69 kilometers in real life. Hopefully you guys got that, and if you're not, again, bring your stuff to class tomorrow and we will work on it together. Okay, last one. Happyville and Smallville are 155 miles apart. On the map, the distance between the two towns is 2.5 inches. What is the scale of the map? So, when we measured on the map, we measured 2.5 inches. And in real life, Happyville and Smallville are 155 miles apart. So, how could we figure out what the scale is of the map? So, to do that, we're going to take 155 miles in real life, and we're going to divide it by the 2.5 that we actually measured. And 155 divided by 2.5 is 62. So the scale of the map is 1 inch to 62 miles. So for every 1 inch you measure, that is 62 miles in real life. So we would want you to write it in this notation. Hope you guys understood all that. These are pretty short notes. I hope you guys enjoy your night and come back with all your stuff tomorrow and we will work on the problems. Have a great night.